Can we start, ma'am?
Yes, ma'am.
Okay, so welcome back. We'll go with dimensionality reduction and I'll see to that I'm sticking up with the time. So dimensionality reduction is nothing but basically it is used for feature selection. So when you have some 4 or 5 features and you don't know which one to drop, then we go with this PCA, principal component analysis. So it is going to give us the important features and it is going to show us how you can go with the reduction of the features. Okay, you can see it is going to cut down the amount of features fine in the data set, retaining the important ones. That is the main thing. So you can see here I'm just taking 2 features, x1 and x2. We'll be having so many parameters for everything. So when we say introduce about yourself, we say my name is so and so and my qualifications are so and so, and I had been working in so and so place, I am working in so and so place. All those things will be there. So for each and every input, we will be having so many features. So now for this example, I have taken 2 inputs and I have taken 4 features. Fine. So here I'm calculating the mean of x1, x2. Fine. And I'm checking out the centered mean. And then covariance matrix. Fine. Like how for regression we have correlation as the important factor. For PCA, we are going to have this covariance matrix. Fine. And then finding out the eigenvalues and eigenvectors. With those, we are trying to group them together. So you can see here, I will be getting my eigenvalues to be the same diagonal wise. Fine. So for all the 4 features, using this eigenvalues and eigenvectors, I am trying to reduce them to, I mean 2D, I am trying to reduce them to 1D. Fine. So that is what is this principal component analysis says. So this is GMM. If there is time, we'll see about it. So principal component analysis, you can see reduces the data dimensionality. Okay, suppose I'm going to give PCA. Fine. I have so many examples. I wanted it to be reducing it to 2 dimensions. And it says that at least 2 numerical features I need to select. So I'm taking example 1 and 2. So there are 4 steps. Fine. So you can see here example 1, example 2, the values. Fine. You can see the covariance matrix is found. Data is being transformed. Fine. So from the 2 dimensional values, you can see I'm able to get PC1 and PC2, which are just single dimensional values. Fine. So this is about PCA, that is principal component analysis. So where it can be applied is basically image compressions and data visualizations. Now with that, your ML is coming to an end. Stepping on with the second session, natural language processing. So, like ML, I can say you right now, this NLP, LLMs are becoming the trending topics. Can anybody say why? You want to put it in chat or you can open up, anything is fine. Why do you think LLM is becoming a trending topic like AI and ML? Are you people
Now
back?
people started depending upon AI tools for content generation and all those things. That might be the main reason.
Okay. What else? Content. Is it only content generation?
No, that is one of the applications.
Yeah. Yeah. One of the. What are the other things? Why is LLM blooming all of a sudden again? So what happens? Most of us have become more dependent. Okay, due to generative AI. Okay, I can also say that. Yes, ma'am. Okay, so we can see that most
Whatever
of
language
us.
we can,
Come again.
whatever language we can access easily.
Okay, so you are saying that LLM has become more prominent nowadays. That is also one of the reason. Like, we immediately go with Google Translator to find out if there is a foreign language into the sheet, whichever we have got. Summarize information. Okay. Uh, Summarization is also one of the thing. Basically, nowadays, like we depend more upon Google, and we depend more upon Google Map. Even though we know the routes, at least to see how much time it takes for us to reach, we depend. We even for the known routes, we put the Google Maps, right? And even though we are able to see outside what is the weather condition, what is the climatic condition today or now, we still ask Alexa what is it going to be today or tomorrow, whether it is going to rain or not, something like that. So we tend to talk more than to type. How many of you agree with me? Most of the WhatsApp messages, we don't think about others, whether they are in a working state or whether they are in the listening state or not. Rather than typing, we send voice messages because it is easier for us. We are not bothered about them.
Yes, ma'am, you're right.
All right. So we wanted basically the machines to go on with conversation. We have become more lazy, more and more lazy, I'll put that way. Before, we wanted the machines to work for us. Now, we wanted only the machines to listen to us more rather than we asking it to do something else in typing. Fine. So, that is why the LLMs have again, like NLP is the basic model, I can say you. Large language modeling is what they are talking right now. But both of them have the base models. Fine. So if you see that way, like as I told you, we tend to go with more conversation. So your mobile phones, it keeps listening to each and every single word you talk, right? Your social media, or if you are going to book a ticket for Delhi, immediately what will happen in your Facebook or in your YouTubes, when your history is on, it keeps giving you about Delhi's reels or whatever is over there, right? So if you're going for a foreign trip, then once you book the ticket in any site, you put it in Make My Trip or you put it in any site for that reason, immediately the next day onwards you will be able to see that in your Facebook or in your personalized social medias, you'll be getting the things about them or about that place. Fine. That is basically because everything has become a conversational bot nowadays. So your phone is listening to each and every word, every single word you keep talking. Fine. So that is why LLM is blooming right now. So NLP also is nothing but it is a base of large language modeling. So why do we say as large language modeling is because English is a common language and it is being used everywhere. In NLP itself, like if you are doing a research, fine. Then if you are going for your native languages, then it is called as a low resource language. Fine. So even for low resource languages, we have so many opportunities that can be done. So since we are all from Tamil Nadu, I can say that Tamil, it is a low resource language. Any of your North Indians are here, then even Hindi is a low resource language. Even your own specific mother tongue, whatever it is a low resource language. So if you see, fine, even though Google Translator is there, it doesn't work well for low resource languages. So you still have so many openings to work on with your low resource languages. Fine. So anyway, keeping that apart, what is NLP? If you see, it is nothing but it's a branch of AI that is going to focus upon the ability to understand our language, what we talk. Fine. And basically the text to speech and speech to text, nowadays that is also more, and more opportunities are there for the grammar, the way in which it has been written. Fine. Google Translate also, if you see, it will give you in two different ways. The moment you scan, it will give you the literal meaning of the words. And if you're going to retain, and if your net is really good, then it keeps changing for grammatically. Fine. So that is what is happening nowadays. Fine. So NLP is nothing but the ability to understand the human language and also to respond, fine, to the human language in the language which we can understand. So these are some of the applications of NLP. So we have voice assistants, we know chatbots, voice assistants, Alexa, if you're just going to call immediately, she'll be asking, yes, what can I do for you? Fine. Okay. Voice assistants, when you're using Alexa, if you ask to Alexa, play me a song. Fine. So what song does Alexa play? I'll put it more carefully then. What language does Alexa play? If it was made in India.
English,
Mm-hmm. So you're not having Alexa at home?
Hindi.
Is it a guess?
Of course,
Tamil.
it's a guess. Our natural
Okay.
one.
What is our natural one? Definitely not
Any
Tamil,
language belongs
Vaishnavi.
to us.
No, no, no. Okay, it goes with
Ma'am, can
Hindi
you repeat
songs.
the question?
Okay, sorry. Question is like when you are going to ask Alexa simply to play a song, which language does she play the song? Was my question.
Whichever language we have tuned her to already.
Whatever language you tune her to, she will be playing only the
Based on our
most.
previous conversations.
No, 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 no. When you're going to just
Yes.
simply say her to play a song, she will be able to play a Hindi song, whichever is on the
Okay.
topmost list.
Okay.
Okay, so there is where she's still lagging behind because see, Alexa is actually our personal device. So
Okay.
when it is our personal device, she should be able to fine tune to whatever we had been playing, and she has to find out which is the most played song from us, and that can be played. Fine. Okay, I have given you a research problem. You can work on with that. But generally, it will be playing a Hindi song because it is made in India and that is how it has been designed for. Fine. But when we say it as a personalization, she should be able to give us our list of songs. Fine. Anyway, voice assistance is basically she, Alexa. Fine. Chatbots, any website you go right now, whether the website gets loaded or not, the first person who asks you will be, how may I help you? Fine. And they also keep a name for the chatbots. I am so and so. How may I help you? Fine. So chatbots are there nowadays. Then autocomplete tools, again, here also. The mobile phones, when we start typing in our WhatsApp, automatically it keeps giving us the words, fine, making our work even more easier. Then language translation, just now I told you. So if you had brought in any foreign products and if you want to see what are the instructions being given. You see Google Translator, it will be able to give you. Sentiment analysis, yes. But nowadays, sentiment analysis also is becoming a challenging task because of emojis and short forms and other things. Fine, text extraction. So somebody already told summarization, right? So as it is in newspaper, we'll be reading. We'll be reading what? For sure, I'm very much sure all of you had just read the
News.
newspaper at least. Ah,
News.
wow. Newspaper, you'll be reading news. You should be more crystal clear.
Sports.
Headlines, bold,
Headlines.
covered.
No, headlines. Fine. So the
Headlines.
first thing which we'll be seeing is headlines. Only if the
Headline.
headlines is impressive, then we'll go into digging it deep. There are some persons, okay, like the person who told sports, they'll directly go to the last page to see only sports. That is also there out of interest. Fine. So text extractions are nothing but like going on with the summarization. Fine. Only after seeing the summarization, even if you're going to take a research paper, what is the first thing you do? Read the abstract, read the summary. If everything is fine, then only you go inside and read. Right. And then context moderations. Again, this also like context generation. Nowadays, you just give a paragraph, you'll be able to get a PPT. Right. So all those are happening right now. So these are the applications of NLP. Now, technology is involved. We have computational linguistics, rule-based modeling. Fine, rule-based modeling, basically in legal law, especially in traffic legal, I mean traffic sides of law. Fine, because when you are jumping red, fine, a signal, jumping the red signal, for sure, this is the fine. So when you are hitting a pedestrian, when you had a red light and you didn't stop and you rode your bike or your bicycle or your car or whatever it is, and you have hit a pedestrian, then that has a particular rule, IPC section, and this is the fine. Fine. So there are certain rule-based modeling yet. We have in AI rule-based systems. Fine. But it is almost like it has been ruled out, they are saying, but rule-based system is not fully ruled out. There are still rule-based modelings existing. Fine. Then machine learning and deep learning, obviously. We know like for context generation and when it becomes a personalization, right? Your WhatsApp messages or your WhatsApp, the dictionary, whatever is coming at the end of your screen is not going to be the same as mine. Fine. So because it has been more personalized, so more deeper the system has learned about you. How do you type? So when I put, if you see like especially the festival days, when I'm going to put Happy Diwali, fine. So first 5 members or 6 members, I need to put happy and then I need to search for Diwali. Seventh person onwards, what will happen? The moment I put H, what will happen? Nobody tries. Wishes
Happy it
everybody.
will come.
Yes,
Happy.
happy Diwali
Happy
itself. Happy also will come. Diwali will be there in the down, very at the second place itself. Right? So happy Diwali, you will be able to do it even more quickly. Fine. So that is what is deep learning doing. So conversational AI systems, predictive analytics are the more challenging task. I can say you, right? Like right now I told you. So in Google, whenever we ask for something, it keeps asking you the locations, right? But in Alexa, once we switch on Alexa, it doesn't ask us or it doesn't take it on its own, right? If at all, if it has taken it on its own, then maybe it would have been a fine-tuned version. So when I'm asking it to play a song, maybe it will be going on with the regional ways of playing the song. Fine. So anyways, so the thing is, my point here is we have more challenges that has to be still addressed in conversational AI and predictive analytics. Again, when I say predictive analytics, legal law again, because why I'm very specific with legal law is we are working with legal law and predicting the legal cases. Fine. Even though we have so many IPC sections already, article numbers already been for years. A case when we take, we are not able to fix them to any prediction. We are not 100% correct. I'll put that way. Fine. So even though any kind of similar cases we train the models, fine, we are still not able to reach the limit of how AI or machine learning has reached in other fields. In legal law, for Indian legal law, if you open legal law, you have European legal laws, you have Chinese legal laws. They have a different kind of systems. But Indians, we give more weightage to emotions and stories, right? So here, predictive analytics for Indian legal law is really a challenging task. Right? So conversational AI systems, all Alexas and then ChatGPTs. Even ChatGPT, even though now we have mm, so many problem solvers in ChatGPT also. When we are asking ChatGPT to give me a PPT with all images, all solved problems, it still keeps lagging behind. Fine. So it is not up to our mark yet. Uh, okay, predictive analytics also. So in NLP's challenges, if we see, the main thing is the ambiguity. Fine. So when I just simply put bank, or if I put tree. So when I put tree in Google search, what do you think will be given for me? Tree. TREE.
Any apple tree are like this, ma'am. Maybe, madam.
Okay. So if at all, this is my first search of tree, like sir said, it will be giving me some vegetative trees. Fine. But if I had already been given a search for my trees of data structures, fine, then I'll be given with B trees or avial trees or something like that. Fine. So that ambiguity is actually the hardest challenge which we have in NLP. Fine. And then coming on with the scale, right? So we have English itself, all different versions, British English, American English, Indian English. Fine. So the scales, the sparsity, the variations. So each and every word, the accent in which we talk, everything matters. Expressivity also. Fine. So what happens nowadays? Kids, what do they say? When we ask a question, their answer is IDK. What is IDK?
I do not know.
Yes, I do not know. Kuda they will not say, I don't know. That is even more a shortest form. Fine. So now research is going on for these short forms also. If you see for the natural language processing, fine. LLM models, even these are being put into the dictionaries. Fine. So unmodeled variables, again, when a new word like this IDK is going to come, then what happens? Fine. Unknown representatives. So when I'm going to put, say, suppose for an example, if I'm just typing the word committee wrong, fine, automatically it goes with double M, double T, and double, fine. So it goes with an automatic changes. So these are the phases of NLP: lexical analysis, syntactic analysis, semantic analysis, discourse integration, pragmatic analysis. So we'll just see what are they one by one. Lexical analysis is the first step. So when a paragraph is being given, it will be broken down into tokens. So here is an example. He does exercise. Okay, the spelling is wrong. So he does exercise regularly. Fine. So I can see he is being taken separately. Does is being taken separately. Exercise is taken separately. Regularly is taken separately. Full stop is also taken separately. Fine. So each one of them is a token. Now the second step is syntactic analysis. So it is being checked for the structure. Chennai goes crazy when we say, is it a proper sentence? Chennai is a place. when it is being named as Chennai as a place, we cannot say place is going crazy, right? So you can, the parser will reject it for sure. Semantic analysis, you're going to check for the literal word, literal meaning for each word. So if you see here, I am just giving colorless green idea, which means it means that I've got an idea, but I don't know how far it will work. That is what is the literal, that is how we talk. Fine. But the parser will not accept it. It will simply reject it. Semantic analysis. Next is the discourse integration. So it is going to see each and every sentence's impact before and after. Fine. So he wanted that purse or something. When I say that here represents that that is being already been spoken. Fine. So it checks for the impact of every sentences prior and post. Pragmatic is nothing but you're going to be seeing the set of rules that is going to be applied. Fine. So when I say order pizza, it is actually an order. I'm not giving it as an request. Fine. So those kind of English, how do we express? Fine. Those comes under these pragmatic analysis. Now, these are the steps which we have in NLP. We have 5 phases. Fine. So lexical analysis, syntactic analysis, semantic analysis, discourse integration, pragmatic analysis. These are the phases of NLP. Now coming on with the steps that you need to follow. Segmentation. So breaking of the entire document. Tokenization. Just now I told you. So every sentence, it is going to be converted into words and it is being taken as tokens. The next step is removing stop words. So here again, non-essential words, that is full stops, commas, hyphens, numbers, all those are removing stop words. Again here, I wanted to mention you something. When we are going to take legal law, fine, Indian legal law, if you're going to take, this removing of stop words cannot be done. Why? If anybody is awake. Why do you think I cannot go with the third step?
I do not know, madam.
Okay, sir, you are not the only person anyway. What about the rest?
Hmm.
The stop word may be a token, madam.
Obviously, stop word is a token, but we are talking about Indian legal law system. So why can't it be removed? Is my question. So we always say IPC section followed by when there is an article. Fine. Say suppose we say some 400 IPC section 400 la I am talking about clause A. You had seen this, what is it, Vijay's movie, no? He, for the oath, he'll come and say this IPC section, clause number, and that clause number will be with an extension, with hyphen, fine? And it will be a number with a hyphen and with an IPC near the mode, we'll putting a dot, fine? So this step, we cannot use it over there. So general summarization, when you're going to take there, you can go for these NLP steps. But again, when we go on with the customization, not always it is going to be the same. Fine. So stemming again is the fourth one. So word stemming is finding out the base word. So when I write hiking, it is nothing but the base word is hike. So that is what is stemming. Lemmatization, again, when I say the root stem, fine. So I can have so many words having the same meaning, fine. So what is that word that is being present in the dictionary? Why did I use IDK? Because IDK is the one which most frequently we use. Fine. BTH, BTW is what? By the way, that is becoming less. Fine. So the root is nothing but the one which is most frequently occurring. And then parts of speech tagging. So nouns, verbs, articles, how do you put them as? Fine. Named entity is nothing but again classifying the words into subcategory: person, thing, or what kind of object it is. All those comes under NLP steps. Fine. So I am done with the NLP basics. If you have any questions, we can go with the questions. Otherwise, I can show you some of the ML techniques which we had left out, GMM and other things. First, we'll go with this. I'm open to questions.
Participants, you can directly ask the questions or you can post the questions in chat box.
Okay. Yes.
कहेंगे
Yes, sir.
कहेंगे
If we have emojis, how will we find? Okay. Emojis, like right now, if you take your phone and put also, nowadays emojis, they are giving it as a labeled entity. Fine. But when we are taking it as a process, emojis are not considered. They are simply deleted. That is why in sentiment analysis,
development training program.
if you take the websites, I mean social medias, we can see most of the request or most of the responses are emojis, right? So now for emojis, labels are given. So with the labels, it will be converted. Welcome. What are the research areas in NLP? How NLP future is prompt engineering? Okay. First, we'll go with Sujita Mam's question. What are the research areas in NLP? So all the applications, I can say you, it is all research areas. If you go to an industry, fine, like none of them are happy with Hugging Face or the LLM models, which we use it for free. Fine. They wanted their own specific data sets. For example, when we went with ocean technology people, fine, they you know that we have a data set which is consisting of all the fishes available in the ocean, fine, but they wanted to talk or they wanted to identify only the fishes that is present in our Indian Ocean alone. Fine. So they wanted it very specifically. They don't want, they are least bothered about the other fishes. So similar to that only is this NLP also. So when we are taking a banking sector, fine, they wanted it very specific to their banks. So when we are developing a chatbot, fine, you have to be very specific about what is Indian Bank giving me? Then if you are developing it for SBI, what is that giving me? Fine. So as I told you before, nowadays we wanted everything more of personalization and customization. So chatbot right now, whatever ChatGPT also, if you're going to say, if you're going to give a question, it is going to give you all in text. But what do you want? You cannot sit and read the pages. You want a summary, right? So if I'm asking the ChatGPT to give me a trip of 5 days, it gives me 5 days of entire trips details. Fine, but it doesn't give me whether that particular day the park or whatever it is it closed, or if that is a local festival. Fine, so those things are still not been done. So if you are planning to do, then you can go with the customization itself in a more customized way. And how NLP future in prompt engineering? uh for this question I should put this way, like when we were kids, right? Hopefully, all of us are in the almost the same age group. Okay. When we were kids, for maths, we used to sit and work a lot. As in, we used to practice a lot. How many of your kids are practicing maths now? Even for maths exam, they read it and go. I think fine, because that is what is happening in my home. Not all of them sit and work out, right? So that is what is going to be the future. After COVID itself, many kids, they don't write. They have forgotten their handwriting. They have left almost how to write also. Even in our college exams, most of the time the people are sleeping. If we ask, they are saying they are lazy to write. Fine. So you can see what will be the future for NLP. We want everything to be very much customized. And you can see now, like all the kids, or I cannot say kids, all of them, they have their own earpods. Even in a bus, also they'll sit with earpods. When they are sitting with their friends, also they'll be sitting with earpods. No one is ready to open up with anybody. Fine. So here afterwards, chatbots are the one which is going to live with us. So that is how our future is going to be, and that is how the prompt engineering is going to be. Any more questions? Hmm. Okay, if there is no questions, do you want me to continue with the one or two ML models, or shall we wind up the session?
Continue with ML models, madam.
Okay, sir.
Yeah,
What
models
is
please, ma'am.
LLM? Okay, what is LLM is, we can say, as I told you before, it is large language model. Large language model is nothing but whatever we are, whatever Google is doing. That is how I should put. See, Google, when we put, I think you're all aware of page ranking algorithm. So when we search something in Google, how does a particular website top up or get the first place? Fine. So it depends upon the person's clicks, the searches. How many of them are or I should put you, like the most of them who is seeing a particular website, that will be given the first rank or the first as a first search. Before, when whatever it is, Wikipedia used to come in first, but nowadays it is not always Wikipedia. Wikipedia is not at all coming in the search list also. Only for certain things or max related things, Wikipedia comes. For the others, it is all like personalized URL address or university's URL address only comes. Fine. So, and in that, everything is text. When it is concerning text and when it is concerning the human languages, then everything comes under large language modeling. So basically, as I told you right now, so for machine learning itself, we are trying to, you can see how many books are being written, right? So when we are going to process all of them, that becomes a large language modeling. And now NLP only is being switched over to large language modeling. So much of data is there, and we are trying to get all those data, either text to speech or speech to text. When you're doing that kind of conversion, then it becomes an LLM. Okay. So going on with okay. At another model of clustering, fine. We call it as K modes. Like K-means algorithm, there's something called as a K mode. K mode is nothing but when you have the scales. As I told you, when you're going to a hotel, they ask you for a feedback. When you're going to, even nowadays, even in jewelry shop, the person who is taking care of you, they ask for reviews, right? So you give them on a scale of 1 to 5, right? Anywhere you go, feedback system is a must nowadays. Fine. So though for those kinds of data, for those kinds of repeated data, we'll go for K mode. Fine. So if you see over here, I'll show you the data set also. So you can see yellow, square, medium, plastic, metal, plastic or metal, medium or large, square or triangle or circle. These are the things. Smooth, rough, fine. So when there are going to be repeated data, then we'll go with this. So you can see here. Here we cannot find the distance metric. Rather, we'll be seeing for the similarity or dissimilarity. I'm moving it faster. So finally, you can see these are going to be my cluster hits. If you want, I can show it. So you can see this is an example, fine. So I have only ABC categories and there are around 5 questions being posted. So I'm taking some initial clusters, fine. So these are my initial, like my k-means only, I have some initial clusters and then these are my data which are repeated. So I'm going to take each cluster head. Unlike k-means, we took for the Euclidean distance, whereas here you'll be checking for the similarity and dissimilarity. Fine. So since this cluster 1 is with the same cluster, we'll not have any dissimilar items. We'll be having 0. If I'm taking the second cluster and comparing it with my first data set, fine. So you can see here, my cluster head is having C, whereas my data is having A. So it is one dissimilar item, fine. Then here B and C, here also there is one dissimilarity, fine. And A and C, here I have one dissimilarity. Here A and C, here also I have one dissimilarity. So altogether, how many dissimilar items I have? 4, fine. So you can see over here. Like this, I'm going to find out for all of them. And here onwards, we'll use the same whatever we had done in k-means. We'll be taking the minimum item and we'll be grouping them together. So here, how do we find the cluster head is? So you can see here, I have 1, 2, 6, 7, and 8 grouped together. So how do I do the clustering? How do I find the cluster head? I have A, I have A, I have A, I have A, I have C. So which is the most frequently appearing item? That is what will become my cluster head. So I have A appearing 4 times and C is appearing only once. So which will I replace it with? A, right? So you can see here. So for my cluster head, I'll be going with A, And here also A is appearing so many number of times. Here also A is appearing so many number of times. Here B is appearing so many number of times. And for question 5, C is appearing so many number of times. So now this becomes my cluster head. Fine. So if you see my initial clusters, I had A, B, C. Fine. Now it has been changed to AAA, BC. Similarly, I'm going to go for finding out the clusters. For all the 3 clusters, I'm again going to apply the same and check unless and until the clusters are going to be the same, we'll be repeating this. Right? So this is K mode. These are 2 different clustering techniques which we have in general. Than this. So K means and K mode. In density based, DB scan is the mostly used one. Okay, I can go with GMM. Hope you all can understand the Python code. So here I have given the occurrences. I told you GMM is a probability based method. Fine. So here we have just given the flips of 5 flips of coins. Fine. 5 different occurrences and 10 times of each of the coin. Fine. So when I'm making the flips, we are trying to find out what is the most probability or what will be the probability of occurrence of head or tail. Fine. So that is what we are trying to find it over here. That is what is that GMM also does. Fine. This is called as an expectation maximization algorithm. So what is my expectation and how it is being maximized? That is what is EM algorithm. Fine. So if you see here, for each iteration, I am trying to find what is my theta. Theta A is for coin 1 and theta B is for the way in which the toss is going to be. Fine. So if you see after 10 or 12 iterations, I'll be able to give more priority for theta A. Fine. So GMM, what it does is it is going to give only the likelihood. It is not going to give exactly what will happen. We can only say as a guess that my next toss is going to be only head. But it cannot be always true. Whereas my other clustering algorithms, whatever I have, they will be able to tell me to which cluster it belongs to. Fine. So that is the difference between this distribution based and other methods. So centroid based, we had seen about K means and K mode. Density based, we had seen DB scan. Connectivity based, we had seen agglomerative. In agglomerative, we saw single linkage, complete linkage and average linkage. So other than agglomerative, we have divisive. Fine. In distribution, we had seen about Gaussian mixture model. So Gaussian mixture model, inside Gaussian mixture model, we had seen about expectation maximization, which says about the likelihood. That is the most prominent occurrence. Fine. So with this, I'm concluding my session. If you have any more doubts or if you are very particular with any topics, you can let me know. If I have the PPT, I can explain it to you.
Any questions? Yeah, let me conclude. On behalf of the organizing team, I sincerely thank Dr. J. Priyadarshini for taking today's sessions. In session 5, ma'am explained unsupervised learning in a very simple way with examples and solved problems. The session was interactive and everyone could follow the concepts very clearly. She showed how clustering and dimensionality reduction are applied in real-time cases, which gave us a very practical view the way ma'am connected theory with applications, made the session very interesting. In session 6, she gave a very good introduction to natural language processing. For beginners, it was an excellent glance with real-time examples. She explained the important terms in detail and even discussed some open research problems, which was very useful. She also showed how NLP is part of our everyday life, like in chatbots and search engines. She also explained different ML models with examples which gave us more clarity. We truly thank you, ma'am, for your time, effort, and the way you shared your knowledge with us. Thank you.
Thank you, ma'am. And thank you all for the patience and for the comments. Thank you.
Thank you. Participants, the feedback link will be
Thank you, ma'am.
posted in MS Teams now. Kindly fill the feedback form today itself and link will be active for only 15 minutes. Attendance will be taken as per ATAL guidelines and we welcome for tomorrow's session. Thank you.